let's start the video lecture. So, we here are talking about the square integral function. Before that, we will be discussing about the scalar product of two functions. So, in the case of function space, in case of function space, the scalar product of two functions psi x and phi x is given by phi psi is equal to integration phi star x psi x dx. Suppose this is equation number 1. If this integral diverges, the scalar product does not exist. Therefore, if we want the function space to possess a scalar product, we must select only those functions for which scalar product phi and psi or psi with phi is finite. Thus, we see that the scalar product only exists if the integration is finite and doesn't diverges. Now, we'll take the special particular case, a function psi x is said to be square integrable if the scalar product psi with itself, that is psi comma psi, is equal to integration psi star x psi x dx is equal to psi x modulus square dx is finite. Thus, if the function gives a scalar product with itself a finite, then that is called square integrable function. It is noteworthy to mention that the space of square integrable functions possesses the properties of a Hilbert space. That is, any linear combination of square integral functions is also a square integrable function. And second, it satisfies all the properties of the scalar product of a Hilbert space. It is also to note that the dimension of the Hilbert space of square integrable function is infinite because the number of linearly independent basis vectors required to span the square integrable function space is infinite, as each wave function can be expanded in terms of an infinite number of linearly independent functions. A very good example of square integrable function is the wave function of quantum mechanics, that is psi r t. We know that according to Bohr's probabilistic interpretation of psi, the quantity psi r t modulus square dqr is to represent the probability of finding the particle in a volume dqr at any time t centered around the point r. Therefore, the probability of finding the particle somewhere in the space must be equal to 1. That is, the integration modulus psi rt square dqr, that is equal to integration minus infinity to infinity dx minus infinity to infinity dy and minus infinity to infinity psi rt square dz should be 1. Hence, the wave functions of quantum mechanics are square integrable, as the integration of psi rt square gives the finite value. That is, the integral of this wave function psi rt gives the finite value and it doesn't diverges. Therefore, it is a good example of a square integrable function. Wave function that satisfy this equation are said to be normalized wave function. Any wave function which is not square integrable has no physical meaning in quantum mechanics. Therefore, we see that any function to be square integrable, it is necessary that it follows the condition, that is integral of psi modulus square dqr is equal to finite, that is scalar product of psi with itself psi gives the finite value. Only then the function is said to be square integrable function. So friend, this is for now. Hope you enjoyed the video lecture and get about the square integral function. So friends, after watching this video lecture, if you like this video, please share it with your friends and colleagues, and please press the like button. If you are watching for the first time, please subscribe